Hmm. Good evening, everyone. Today we will discuss the topic governor. So, first we will study what is a governor, then what is the basic difference between governor and flywheel, and what the types of governors, etc. etc. So, generally, this governor is a device used to govern something. It's a device used to govern or control. Basically, we can say this governor is used to maintain the speed of engine within the specified limit. So this specified limit whenever there is a there is a variation in the load in the load. So in a simple vehicle, we always see that our engine moves at different speeds. As you are moving on a road, then you see some you are passing through a flyover, then you see as soon as you are just maintain a simple throttle of your bike and you are just moving ahead, then your bike is running over a flyover, then you see the speed is going to be decrease. So in that case, when the speed decreases, you have to control the speed so that it will maintain the specified limit of the specified speed within the limit. So moving over a flyover, what happens? You just increase, you just accelerate bike. That acceleration is governed to throttle, and throttle opens. That increases the supply of fuel, and finally the speed is maintained within the specified range. So what happens? This variation, so we have to maintain the speed of the engine within the specified limit. The variation in speed is occurs the variation in speed occurs because of the reasons. Two types of fluctuations, there are two reasons: cyclic fluctuations fluctuations cyclic fluctuations, and second, fluctuation due to external load. So two types of fluctuation: first, cyclic fluctuation, fluctuations due to external load. As you see, any device or any automobile works on a cycle. Any cycle it may works. There may be auto cycle, diesel cycle, etc., etc., and it has four strokes: suction stroke, compression stroke, four stroke, suction stroke, compression, expansion, and exhaust. So these are certain stroke, and we see in the suction stroke it is required to give power to execute the suction stroke. Compression stroke also takes some power, but in this stroke this is the only stroke in which we get the power at the shaft. So here the torque available at the shaft is more. Here torque available is less, suction stroke torque available is less. Also in this case it is more, and finally it also requires some power to just reduce. And so what is going on, this exhaust stroke, suction stroke and compression stroke consumes power, so the torque requirement is less. So here the torque in the expansion stroke in the crankshaft is more, so due to this torque the speed increases. So these cycle fluctuations can be controlled by putting a device called flywheel. While these fluctuations because of the external loads are controlled by a device called governor. So this is the basic difference between the governor and flywheel, that governor is used to control the speed of an engine because of the cyclic fluctuations. So whenever there is cyclic fluctuations, this governor is used to maintain the speed. But whenever flywheel is concerned, sorry, this is not cyclic fluctuations. This is used fluctuations in external load. Use flywheel used for cyclic fluctuations. Okay, so the basic difference between flywheel, it is used to control or maintain the speed of an engine within a specified limit wherever there is a variation in cyclic fluctuations. But whenever there is variation in external load, we use a device called governor. So somewhere we see that the function or the basic other difference between the governor and flywheel is that the function of, so it is this, the function of flywheel is continuous, while that of governor is somewhat intermittent. So this governor function whenever there is a variation in external load. If you are moving smoothly on a simple road, then obviously there is no need to govern. But whenever your bike is operating, obviously it will operate on a cycle. So a flywheel will work always. Okay, so this is the basic difference. So we are revising the things. Governor, device used to govern or control. So governor is used to maintain the speed of an engine within the specified limit whenever there is a variation in the external load, assuming that you are moving on a road. So as soon as the flyover is coming, then you are climbing over that. So if you are maintaining the constant throttle, the speed is going to be decreased. Then to maintain the same speed, obviously this governor just communicate the things with the throttle, and the throttle adjusts itself according to the requirement. In the next chapter, next case we will see how this governor, or what are the various types of governors, how this governor works. So basically this is a simple centrifugal governor. So before this we can just see the various classification of governor. Classification of governors. Basically, the governors are classified broadly into two categories. Sorry, governors. So there are two types of governors. First is called centrifugal governor, and the second is called inertia governor. Centrifugal governor, we will discuss in detail. Centrifugal governor is that type of governor in which the behavior or the action of governor is controlled by is or depends upon the centrifugal effect produced by the masses of the two balls. Let us discuss how it works. So centrifugal governor, in case of centrifugal governor, its action depends upon the centrifugal effect produced by the masses of the balls. But in case of the inertia governor, only uh, centrifugal force or effect produced by the governor balls. In this, it's we can say it's action action depends only on the centrifugal force or effect produced by the governor balls. In this case, its action depends upon the centrifugal force as well as the rate of change of speed or acceleration or deceleration. Again, these centrifugal governors are classified as into two groups. These two groups are pendulum type governor and loaded type governor. Second is loaded type. Pendulum type governor is, we can say, a simple type of governor or gravity governor. It comes under watt governor. So watt governor is the simple pendulum type centrifugal governor. Loaded governors are again divided into the categories deadweight type and spring loaded. Deadweight type of governors is the Porter governor, and here is the Proil governor. Spring loaded type governor are Pickering governor, Hartnell governor, her tongue governor, her tongue governor, Wilson Hartnell governor, Wilson Hartnell governor. So this is the basic classification of the governors, how the governors work. So these governors are classified into two parts: centrifugal governors and inertial governors. Centrifugal governors are those governors whose action depends only on the centrifugal force produced or centrifugal effect produced by the governor balls. But in case of the energy governor, its action not only depends on the centrifugal force set up by the balls, but also the rate of the change of speed or acceleration deceleration of the balls. Next, centrifugal pendulum type, loaded type. Pendulum type, there are only one watt governor. Loaded spring, whether it is loaded with a spring or deadweight type governors is only the water governor and fluid governor. Spring loaded are these and these. So this is how we can classify the governors. Until now we have studied what is governor, the device used to maintain the speed of an engine within the specified limit. Whenever there is a variation in the external load, you are moving ahead. Sometime you see the load is constantly increasing, then you have to increase your throttle edge. Whenever you are moving over a bike, then obviously you are just climbing, then you just accelerate your bikes by just turning its handle. रेस जो रेस देते हैं ना, वही रेस देंगे तो जिस वजह से आपकी बाइक आगे बढ़ेगी। और तो जो रेस से क्या करते हैं हम, फ्यूल। तो जनरली जो से उससे हम क्या करते हैं, फ्यूल की सप्लाई बढ़ाने के साथ साथ पावर प्रोडक्शन बढ़ जाएगा, जिससे स्पीड मेंटेन हो जाएगी। Flywheel, the function of flywheel and governor is only this thing: flywheel control the cyclic fluctuations, while governor controls the external fluctuations. There's a basic difference between the two things. So next we will discuss how basically how the function the centrifugal governor works. These are simple, you can say, working how a simple governor controls the throttle, or how is it work. This is a simple working of a simple centrifugal carburetor, and this simple you can say the watt governor in this case. So generally the basic components of this governor are, these are two arms, that is called the upper arms of the governor. Two masses are attached, or two balls, mass of the balls are attached. These two balls are called the governor balls. These are lower arms of the governor, and these arms are just connected to the sleeve. The sleeve slides along the spindle. This is the spindle, and the upper arms are just crossed or connected at the spindle at this point O. You can let this point is O, and this is the sleeve. The sleeve slides along this spindle. These are the stops that just prevent the motion of this sleeve in above this one and above this one. So it can move at this point, it can lower at this point. This spindle is connected to the engine with the bevel gear at 90 degree, and these are the spindles. We have discussed all the things. This sleeve is then connected with a bell crank lever. This lever is called bell crank lever, and this is the carburetor connected. So considering the case, suppose your engine is moving initially at some speed, so this is the plane of rotation of the balls. As soon as you are just simply let the case, the simply wrote, you are moving over a bike. Okay, you are rising over somewhere, you are rising. You are moving ahead. Whenever you comes in contact with this road, initially let your speed is whatever the speed. As soon as you are climbing over this flywheel, what happens, the speed of this engine is going to be decreased. As soon as the speed of this engine is decreasing, then what happens, this spindle is moving slowly. So because of the motion, these balls are like this one, these balls are rotating along this plane. So when the speed is decreasing, the centrifugal force produced by the decreases, so these balls moves along this directions, that is try to moves at a radius less radius from the spindle. So this these balls comes in the downward in towards this axis or this spindle. So due to this motion, this sleeve moves in the downward direction. This motion of this sleeve is then communicated with this bell carrying lever. एंड देन जब जैसे ही इस बेल क्रैंक लीवर से इसका मोशन कम्युनिकेट होगा, तो कम्युनिकेट होने की वजह से दिस बेल क्रैंक लीवर विल जस्ट turn the throttle and adjust in such a way that it will increase the supply of this fuel. So it will open and increase the supply of fuel. As soon as the supply of fuel is increased, then obviously the speed fuel burns in more quantity and then the speed increases. This is the case one, how it is controlling when your speed, this vehicle is moving in upward direction. So to maintain the same speed, it increases the throttle and maintains the power supply. In the second case, when you are moving in the downward direction with your flywheel, then obviously your vehicle will move with higher speed. So what happens, whenever this vehicle is moving higher speed, engine shaft is increases, this spindle is also increased with more velocity. So what happens, this balls moves very fast. So due to this fast, the centrifugal force increases, and this centrifugal force will try to the centrifugal effects will move these balls in the outward direction far from this spindle. So what happens, the sleeve will try to move in the upward direction. The motion of the sleeve is then communicated with this pelcring lever to this throttle. It reduces the throttle, so that is decreasing the supply of fuel. जैसे फ्यूल की सप्लाई कम होगी, स्पीड कम हो जाएगी, it means it will maintain the speed of an engine within the specified limit. This is all about how a centrifugal governor works. This is the most commonly type of governor used in the present cars or etc etc. So we will discuss in detail the inertia governor at last. Now let's have a look on the derivation or simple a watt governor first. So this is a simple diagram for a watt governor. This is the same whatever we have discussed in the earlier case. So this governor, maybe there are three types of governor. Three type watt. There are three arrangements, simply we can say these are the arrangement. So these are the balls, governor balls, and this is these are upper arms, lower arms, this is the sleeve, and we are assuming. So this is a simple form of this watt governor, simple form of the centrifugal governor, simple form of centrifugal governor, that is a gravity type of governor. There are three types of governor in this case. The governor may be open arm. Three arrangements are open arm, closed arms, and crossed arms. Open arm, closed arm, and crossed arm. Let us discuss one. In this type of governor, these are the upper arms. when these upper arms extends and int and are connected at the axis of the spindle. So this type of arrangement is called closed arm type centrifugal governor. Closed arm type. That is, the upper arm intersects connected at a point uh, on the axis, spindle axis. Okay, intersection point. The second arrangement may be the case when this is the spindle axis, these are the balls, when the two upper arms are not connect on this spindle axis, but these upper arms are connected with a horizontal link like this. So this type of governor, this type of arrangement is called open arm type governor. Open arm type, that is when the upper links are connected by a horizontal link. That is when upper links or arms are connected by a horizontal link. Here the upper arm are connected at the spindle axis. And the third arrangement is cross type. So this cross type is when in this case what happened, when these two the arms, that is the upper links, cross the spindle and are connected by a horizontal links like this spindle axis. These are the ball mouse balls. These two arms crosses the spindle axis like this and then are connected by a horizontal link. This arrangement is called the crossed arm type. Crossed arm type. So this is called crossed arm. In this what happens, the upper link cross the spindle the upper link cross the spindle and are connected by a horizontal link. So they are the three arrangements. This is open, this is closed type. Closed type, open type, this crossed type. So now let us have the simple. So now you can define a void governor. A void governor is a simple pendulum type or simple centrifugal type of governor that have two ball masses whose upper arms are connected at the spindle and the lower arms are connected with the cylinder. So you will just explain whatever I have explained in the last figure. So as soon as the speed increases, so various forces. Now to analyze this simple governor, let theta is the angle made by the upper arm with the vertical. Let M is, to analyze this, let theta is the angle made by upper arm with the axis, with the spindle axis. Let M mass of each ball. So mass of each ball is M. At this point is O, this point is A, at this point is B, this point is C, this point is D. M is the mass of each ball. Let H is the height of governor. Height of governor. Height of governor is the distance between the plane of rotation of the ball. These balls are rotating along this plane. So, and the point of intersection of upper arms to the spindle axis. This H is called height of the governor. Let W is the weight of balls, weight of each ball. Let weight of each ball. Omega is the angular speed, angular velocity of a spinner. Let T is the tension in arm. So the T is the tension in this arm, and because of this spindle is rotating with some angular velocity, the force acting on this will be in the outward direction. Only same in this. We are analyzing on this left half. The force will be mr omega square. Its other force will be the weight. It will move in the downward direction. These are the various forces acting on this. Let this is r is the plane radius, or let r is the radial distance of ball centers from spindle axis, spindle axis. Okay, so this is spindle axis, these are the ball. So this is the radius, r is the radius of between these two things. And so the forces acting along this, and we are assuming the links to be massless, and the friction of the sleeve is negligible. So these two things we are considering. So the very forces we are considering the equilibrium of left part of the governor. So the left side of this governor, we are considering the equilibrium of that part only. So that is the equilibrium of this side. So if this is A, this height we have considered this one. So when this point A is in equilibrium, this mass ball A is in equilibrium, then the forces, if this is T, so a component will be along this, component will be T If this is theta, this angle will also be theta, so this will be t cos theta, and a component along this side will be t sin theta. So considering the balancing, so applying the conditions of equilibrium, actually there are two methods to calculate this height of the governor, a relation between the height of the governor and the speed of this flywheel. One method is the equilibrium method, and the second method is eye-center method. So the two methods, there are two methods to find a relation between the height of governor h and the angular velocity of the governor, whatever the angular velocity. First method is the equilibrium method, and the second method is eye-center method. We can consider two methods one by one, but in this case we will study this equilibrium method, while the types of governor we will go to this one. So applying the equilibrium, so applying the conditions of equilibrium, conditions. So upward force is downward force, and leftward force is equals to rightward force. So applying the condition, that is t cos theta is equals to mg, t cos theta is equals to mg, that this is equation 1, and because this is the t cos theta upward, downward force is mg, rightward force is t sin theta, leftward force is mr omega squared. So rightward force is t sin theta, t sin theta, it is equals to the leftward force is m omega square, mr omega square. This is equation number 2. Dividing equation 2 with equation number 1, then we see t sin theta upon t cos theta, it is equals to mr omega square upon mg. This will be cancelled, m will be cancelled out, and this is tan theta. This tan theta is r omega square upon g. But in this triangle O, in this triangle, if this O, A, and that this may be a point, the tan theta will be, this is t, tan theta will be this perpendicular upon base, and this perpendicular is r, this base upon base is equals to s. Since tan theta is also is equals to, tan theta is perpendicular r upon h, put this value, so r upon h is equals to r omega square upon g. This r will be cancelled out with this r. This implies that this h is equals to g upon omega square. This is a relation between this. Also solving this one, or this h is equals to, as we know, g is 9.8 and omega is 2 pi n upon 60 square. So after solving this, we will get a relation that h is equals to 895 upon n square. This is a required relation between the speed of the governor and the height of the governor. So this is the basic relation, required relation. But in this case, we can say if n is 1, h is obviously 895. If we are increasing n to this, obviously, we see this h is directly proportional to the square of this velocity. So when this n is increasing, this variation in h is small. That is, when n is more than variation in H is less. So this governor is not much sensitive or is insensitive at higher speed. So this is till now discuss only we will discuss till here, and the next thing we will discuss in the next lecture. Obviously the numericals we will solve the numericals of each and every type of governor in the last in the last lectures, but till now we will just cover the theory part of this one. This is how a void governor derivation can be or how we will analyze the problems of void governor. This is the basic relation required. So I think till now we have studied the things basic. So points we have covered is what is governor, we have covered this one, that is device used to maintain the speed of the engine within the specified limit. Function of this, why do we use a governor? We have classified the governor, what are the various types of governors, difference between the governor and flywheel, governor and flywheel, we have studied this one, the difference between the two things, and working of a simple centrifugal governor, simple centrifugal governor, and obviously the analysis and description of what governor. Okay, so this is the basic till now the points we have discovered, and the main analysis will remain same, but if you can understand the analysis of Porter governor, then you can analyze every governor in this case. Okay, so okay, take care and good night. One thing, if you are having some suggestions what things we have to cover, if you are facing any type of problem I am not clearing, you can write it in the comments section, and I will read and will try to cover all the points.